Okay, getting started. Yeah. So this is going to be interesting. What we have, just let me check that this compiles right now. We need a piece of code to compile to. This is some initial work that I haven't finished yet. Okay, so we have a few things that we want to change. The first one is going to be like you have a function int foo, and it's going to take maybe a and b, and default arguments are, I don't know, 3, 2. Okay, and then it's just going to give you a times b plus a. I don't know, like that. And this should compile fine right now. Oh, okay, we have already used foo, so let's use bar instead. So this is nothing new, but when we call this, we want to do like call foo b equals 5. Okay, so right now this should work. I'm going to say b equals 5, and we'll run that. Oh, it wasn't foo. It was a bar. Okay, and when we run this, we see. Okay, I didn't do it. So now b was usually it was 4 if I had nothing. Well, let me show that as well. So call bar, and we have yeah, like that. So we should now see the difference between the two, and we have 10 and 12. So that's what we expect. I'll just turn on the webcam so you can see my face. For no reason at all, but I guess it's nicer to see someone talk, I guess. Okay, so what we want to do is, this is supposed to be like this still, but instead of doing this, we want to be able to do this. So we're just going to use that sort of syntax. Now, actually, I spent a lot of time making this work. So we're doing something, I have a lot of fix-ups in order to make this work, which means that all these fix-ups need to be rolled back. But we start, as usual, in the parser, because we want to change something with the parsing, and it's the parser for the expressions. When you get into one of these, this is a call expression. Let's see if I can get the call here. So token something, where is the parenthesis? We have parse call anyway. We have somewhere parse catch bang dot parenthesis somewhere. I know I have it sort of ordered, but here's obviously at one point in time I stopped doing the ordering here, and so that was not so nice. I guess these are reasonably together, but okay. So question something, here it is. So when it's at the end of something, we call it a call, and then we do the parse param list, And now we have like it might be this or this, right? And I think this is used by, here are the initializer lists. So we're gonna get those. I guess also in the in some other cases. Yeah, I know, I remember, because this is, so this is for the enums as well. So okay, we have special handling for this, right? So it's one of like this C syntax where you can do like you have a like this, and then you do like, okay, let's say that the second, this one is going to be like this. Okay, so we have, I think we need something like, that's right, this works. So this is that handling. Otherwise we say, okay, it's an expression, but now we want to do like else if token is token dot. Okay, in that case we're doing like special handling of so now instead of this we expect first an identifier that could be we are going to consume the token first because we don't want that, and then we want a bunch of, no, we can, maybe we can just, expression is parse, we have like this this sort of we have like, if you get like this, if you see something like foo dot, like when you get to the dot you start to like, you can expect another dot or something else, right? So in this case after the dot we actually expect more parts. So we expect it to be like when we parse a dot, which is parse something that should be in here. So parse it is possible that let me look. So in the case we get a dot here. And dot. So then we parse binary. And then we have, okay, so we get the binary op and we get like the we just get the binary expression. So and we know the first one will be an identifier after this, so we can do like this parse like we expect now. So this needs to be, let me think. So this must be a an identifier, an identifier. Sorry. So it was a long time since I used this. So okay, consume more. Like once you get, and it's an identifier. It can't be anything else, like a special identifier, or constant or anything like that. It must be small. Lowercase start. So if it doesn't, then we're going to return false because it's broken. Okay. And then now we have the no, we don't consume that. We're going to advance past the dot first. That's the first thing we do. Advance past the dot. Now if token is token something, there's let me see whether we try consume expect, like what does this expect do? Okay, try expect, or okay, expect identifier for expect this one or that one. Okay, we expect a token ident, otherwise we just return false. We can make that nicer later on. So this should be giving us a, if it isn't a dot, then you are wrong. And now we should create a new type of expression, which is an expression actually we should start that up here. So get the whole thing like a new token. We take what's that called? Like a member access, because that's what it is. And we have a context token. And because it's a member access, we have, let's see what the member access looks like. So expression access, we have a parent which will be null. And that's fine. And then we have a ref, and we have the sub element, which is this current token. I keep forgetting context token, right? And that was just a token ID. So you need to get the ID from that. And then let's see what we have more in the access expression. We don't have, this one is just a union. Like when it identifies it, it's done. Okay, so now we have that one. We can actually, you can actually do that later on. We can make consume or instead. Because we can already jump through there. And then after that we want to maybe we want to range extend that expression, and then the expression is actually try or parse precedence with left side being prec what is it call, something like that, or it will return false, right? And after we're done with that, we actually expect we have a so that will be left side of this one, right? And then we have there's going to be like an assignment thing. I don't know if this is correct. So there's the none here actually. We get that one. And then we try, are we going to get an assignment expression here? Are we going to get an assignment expression here as well? Like when we do, first we do this one, right? So we get the whole thing. And then afterwards we're going to get, so we do a try expression or Parser precedence. And now we're instead doing this, and we have prec assignment and false again. And something is wrong here. Oh, okay, so lack of terminator here. And now we should expect that this is like here we should just check that. So expect expect token equals, right? So we expect it to end with an equal sign. We don't really do that here. We do the bracket and then we just do the left side and just assume that it's going to be like an assignment. I think this is bad. The reason why this is bad, I don't remember quite how it's supposed to be, but I think that you want to make sure that this is like this, or it's going to be like all complicated. So consume or here. Just make sure that there's an equal sign after that. Okay. So that is that, and now when we call this, it's going to break because semantic analysis is going to complain. So expect the name of function parameter here, close the assignment expression in parentheses. Right, so we didn't get what we thought we would get, which was an assignment operation with either this special sort of subscript thing, but we shouldn't do this. We should get a new sort of AST node or expression node. Let's add a new expression node. Expression named param. Let's just call it that. And so here we have the subscript, right? And then we're just going to take that one, right? And we're going to have the first one, and then we have another one. So we create the actual expression, which is the expression, what do we call it? Named param. Oh, expression new token. Named param. Expression named param, right. And now after that we have the subscript expression, which is this one. And we have a subscript expression. We do parse that. We take the last bracket, we extend. So now we have our subscript first, and then we expect this one, right? Sorry, this is correct. I need this one, right? And this one. as well. So it's just going to we do parse everything inside of the brackets here. So like create the parameter and then expression, and then parse the inside of this. Okay, and then afterwards include in the expression, and then expect the equal sign after, and now parse the rest. And we can have anything, so let's just do like this. And now of course we have another expression, which is the value. When we have value to this a type of access expression, but we call it named param. Named param, and we need to do that as well. So we have named experience, sorry, named parts. We have the our path, and we have the other one, which is value. So now we could already have assigned that and assign that even here, which is, and then finally we do the next one. We don't need to actually store that while saves this. And now to do this, then the expression entire. So you're going to do this, right? And actually, if it's a dot, then we want to do something similar. Okay, so we are still here. We're sort of going to start by taking named pattern. And now we're going to actually, we have identifier. That would be the identifier, and we are maybe correct to use that. So we know what's going to be. So we parse identifier. Maybe we parse identifier with a path. Right, so it's let's just use that one. I need to declare it up here, and now it's down here. So parse identifier with path. So we take the context, we take a null path, and we should already have checked that is correct. So we want to advance past the dot. We want to expect this an identifier. Now if you have expected it correctly, then we can then anything that we do will be correct here. So we are just going to put that in the path here. I don't know, maybe there's one thing about this is that the way expressions are parsed is that they are basically inverted, right? So you get something like if you have a dot b dot c, what you get is basically a dot b dot c, right? So what you can, when you index, you're going the other way around, right? That's how you do it. The possibility here to do this immediately because you know that looks it is over, and then you can do that recursion here. So the question you do or not. Let me see if someone wrote something. No, yes, something in Russian. Okay. Right. So we could actually do that instead. So we could do a static expression parse parent path. All right. And now we can actually put everything up there. I don't know if this is a good idea, but we're experimenting. Okay, so let's do this experiment. So what we begin with is that we're going to still have that expression, right? So expression is it's going to do the same thing. We're going to take this named param, but we're going to rename it later on. But we have that, okay? So we have this. And then now we know there's a dot or something, so while true. Now we are going to add expressions to a list of expressions. So we have a path, right? So now it's going to be like top down. And now we have our this sort of var array that we do like this. And now we have just two possibilities, right? So we have the possibility one, it is a bracket, right? In that case, we do I guess we do the, like, we want to advance past the left bracket, right? We're going to do that. And then we do the right bracket, and we take everything inside. All right, and now we're done. And so we have that expression. Now we're just going to add that. Sorry. So we do a vec add of the path with this subscript expression. And now we don't know if this will be a dot or something after this. So we're actually going to just continue here, right? Now the second chance is that there's a token is this dot. So that's the second possibility, and that's like actually the only thing we have. So now we can sort of say, okay, so identifier, right? So we have we're going to like go past the dot itself, and then we're going to, I think we're going to do the whole identifier ourselves, not use the this one, parse identify, sorry, parse identifier with path. We are not going to use this. We're going to do that one by hand because we don't need the complexity that it has. So, okay, so we go up here. Again, this is the dot. Now we create a new token, and we know it's we already know we want an identifier. And we know that the token is this, the dot. So it looks a bit different from what we would expect. So here is the ident expression. Okay. Now and now let's say the ident expression. Should we have that? No, we don't need that. Actually, and it's just messing up, like making us do bad things. So that should be gone, and this one's there, and this one is here, and then we add that expression. Now that looks nicer. And then if it's a dot, we just going to create that. We're going to make it an expr. We take the identifier, put the identifier into the, no, we're going to advanced ones. Advance. And then we're going to like, okay, so if it's a dot, okay, there is another possibility here. So if it's a dot, then let's do like this. We have to flag for parsers here. So this looks nice, and if it's a dot, then what I expect now is that consume. Oh, like here, yeah, we needed this. So because we have all these assumptions that we can return Boolean. Okay, so if it's an expect or expect, and then we have the identifier expression, which is the tokenster of the current token, and we also have some other stuff we do for this one. So as a refer, no, this is fine. Maybe we should even do this because it doesn't really like the dot. Okay. Right, and then if we're done, now we can go. We're going to go beyond this one, and then we're going to add this to the path, right? And then otherwise we're just going to break. Anything else, we are done. And we're going to return true here, actually. So let's go through these and parse the path, and we don't even need to have a path. So let's document this. Parse, so param path. Let's see what sort of way I expressed this before. Okay, I don't know if this is the right one to watch. Parse statement. I think these are like probably more recent. I to change some of those to match. Yeah, this looks more correct. Like this is the style I want. I see some technological depth here. So okay, parent path. So that one will be like it is either a this expression, or it is dot identifier. And then we can basically stack these a number of times. Right? So this is all there is to it. Very simple. All right. Okay, so now we are here. So instead of doing this, we have param path. This. Okay. So now if for every parameter, instead we do like the, let's say the path is null. Oh, I don't know. It doesn't need to be null because it's going to handle. So if not parse param path path, then we had some error and we already reported that. We can just go exit that. And if path is not null, then we have a named param this thing. So we want to take the first, like we're going to store the token here. Token ID is the so in the case that happened to be right, then we want to this one to be the current, and we want to extend this. No, we don't want not yet. And then we have named param. So we have the path, but now the path is this instead. Yes, path. And then we expect this one, and then after that we want the actual value here. And now we're done with that. So that was the like the this part. Okay, so those are the two possibilities for the param list. I'll allow type actually doesn't used, so now we're going to get a bunch of errors. So we wanted to add this one, exper named param dump is just not done, and I should be cleaning this up. As like if someone wants to do this, I would be super happy, but it's just too boring because I never look at this. Okay, this is more interesting. So if there's a named param and I need to copy that, I should macro copy expression list, which is the expression. Let's see here. So we have path, right? And then we also want to copy the value. This is to enable having the macros use this. So okay, let's see here. So we have a named param and we do the analyze expression dispatch. And now what we do know is that named param should never be like a normal expression. And we want to omit that. No, we never want to omit that. It's just not going to happen. And now we are a fatal error on analyze expression dispatch. Yeah, because now what we do is, like we're going to have this, we have different places where we want to do this. So one is the call expression. Let's see here, call, right? So what happens is we're going to analyze that one, and then for every let's see, we have the var call, right? And we have the func call, and we have the generic call. And they do sort of do the similar thing. And we're going to go here and going to go through the arguments and look at this. So if it's the argument is, a binary, and then we're going to assume no, this is wrong. So if it's not implicit, it's actually less than struct args. I don't remember what the struct args things was. All right, so it's hang on, it's the first one can't be this one. So anyway, it's going to be if not implicit. Oh yeah, because it's like putting the first one as implicit. So, but it's of no concern because we are never going to get that anyway. So we have if the arg is expression name param. Now we are using name parameters, and let's find the index of that named parameter. Let's see what that is. And so in this case, we know that we cannot have a race or stuff like that. So we only expect. Okay, so this is not the error. So we only expect. We take the. No, that's the error. This is like the path, right? So we have the path, right? And let's see if we use that for other things. No, okay, we don't do that. So okay, so we'll take the path, and that's going to be like this, right? Okay, so if vector expression expers is not equal to 1, then sigma error no, hang on, it's going to be like it's going to take the whole thing, right? It's better that way. So we're going to take this one. So if the exper named param exper path is not 1, then we take like this one, say expected expected the name of a function parameter here, and did you this looks like a member path. And then that's an error, so we have like -1. Then the second thing would be if then we have like element is exactly this named path 0, right? So if that one is not an identifier, so then we have the same sort of error here. Looks like a an array path element. Okay, and now we have this. We know that the element is a name, right? And then we have again, there's no name with blah 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 with the name that. So we fail. Otherwise, we find it. So we're done. Okay. So now we have the actual this, and then analyze expression of required type. We try to do that, and then we set that index to whatever it is. Okay. I think this is enough actually to get that to work. Let's see if it works. Okay, and we are going to run this. Let's see if we get 10, 12. Yeah, we did. So now we did a lot of changes actually, and it's going to wreck everything about structs. But this works now. So this is the new way of doing these calls. We can show that we can do after order, or we can take like B is 2 and A is 13, or through 3 and 13. So we have like, okay, let's B is 3 and A is 13. Let's just see that that works. And let's see if what happens if we take this one as well, again, one more time. And I think that should be an error if it doesn't expect that. Okay, there, parameter A was already set 1. Okay, it looks like this one is pointing to the wrong thing, right? Remember this, it's important that the, like in this case, the path should be, the whole path should be marked. So this is probably because I didn't, like we have the path, right? But once we've done the path, here, we need to do this prev extend, so like this. So this basically says let's consider everything up to what we parsed up to here part of that expression. That is going to extend that a bit longer. So get this. Parameter A was already set once. Okay, and then we can remove that. And let's see that we got the correct result here. We got 52, which is what did we have now for that? We did say A times, oh, so it's basically B plus 1 times A. Okay, so that's 52, yeah, number of cards. Right, so now we're done with that. There are a few weird things people are I guess we are getting like these people who are spamming the chat here. I don't know how to like remove this. Well, I'll eventually learn, I guess. So okay, anyway, so that's done. We right now we broke it, right? So we didn't fix some other things, which they're also macros, right? So we have if I do a macro, I should be able to do the same thing, but I don't think the macros will work. So let's do a macro mmac, and it has an A equals 3, A and a B, and the B like this. So okay, so then we have like Mac one like this should work like straight off. It didn't. Let's see if I did this right. Okay, I'm not super sure that it takes these. We can add the default parameters right now. But anyway, I can probably just, I can run the tests, see what breaks. Okay, I clearly have too few tests. So, because everything would pass. But no, it doesn't work. Okay. Let's go back to when we do this call thing. We have in the schema for the calls. So call expression, right? And then we have, let's see here, so we have function invocation. We did that, right? So this was where we handled that part. And that was from the function call. And we got that from here. And then we have the generic call, and that's not done yet. So that explains why that didn't work. And then this just goes for func invocation anyway, so that would work. Right, and then we have the macro call, and the macro call basically, let's see if it takes, and no, I don't think it actually handles the named parameters, and that's something it should do, but doesn't at this point. All right, and then but then we have structs. Okay, so the structs are next. And let me show you what is broken then. So we have a struct. We have structs up here, I guess, as well. Like somewhere now. Okay, so if I have a struct, blurb. Okay, I have this one, and it's an int A and a double B. Right, I want to create one of those. Then I want to do this. Blurb B equals, like maybe this. Okay. So now this should probably break when we get into, the expression dispatch. But there will be further breaks. So let's just go into the expression dispatch. So we don't expect to see that one, and that's because we didn't handle it in the struct declaration thingy. So it's an initial identifier string, whatever that is, somewhere. So here we are, I think. Let's just see where that breaks this. So here we have all these init subscript and so on, because we do it so complicated in the parser. And we just needed that because, and we have this designated path. I think we can remove all of that. Yeah. Okay. Schema analyze expr. Right. If you go here, take this one and do that dispatch, and then we have here. Let's do like this. So let's see where it breaks. Boom. It breaks in here. We do the value thing. We want to do the required type. Plain initializer, right? Because we think it's a plain initializer. Why do we think it's a plain initializer? Because we go through with the 0, and maybe if we have an expression named param, right? This is the rule. Like if we have there. This means in this case we're not resolving macros here. Okay, whatever that means. Otherwise we have a plain initializer. So now we get to the right place at least. We're going to go into designated initializer. So now we expected the initializer on the format blah 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 here. Okay, but we are not because we don't need to do that, this one here, because we already know, okay, we have okay, this is sort of interesting. So at this point here, we are initializing some path. So we have the designated path here, and that is sort of an index and stuff. Okay, this is sort of crazy. And we can remove this. And now we know that we have like the path, right? Which is expr named param expr path. And we have the value, which is expr named param value. Is there a value later on or what? No, it's just this. Okay. And now, like while you're going to go through this one. A path. We're going to take another one. So we're going to go through down, walk down into this path. So we start with the current type. Which is is struct. No, so it's like current type. Current is assigned canonical. Okay. And then we try to find type of path, right? So we have like, okay, we take a type, find type of path, and we take the current type and the path element right now, and then we get another type. If not current, then we are done, because basically that is a failure. Okay, so it's going to return the type. Let's write that one. Static type CMA find type of element. And we have type, and we have an expression saying what the element is. Okay. And that will fail if it didn't. And there's one is, we didn't want to know if this is constant. So we have a like is constant is true by default, and we have a bool is constant. Like that, sorry. So now, okay, if it's not a, like this is not a valid member, so if it's, if not current, right? So if not current, then we just break. And then if not, well, we can might have reported this error before. So there are two possibilities. So if current is not 0, there's not current, and did report error like that, and we did report error. In that case, we report the error. So why is this a problem still? So it's going to what variable? Oh, the index one. We can actually move this out of everything now that I'm thinking about it. So so now we can, let's see here. So we have this part here. We have the type, original type, which is okay. So then we have a single expression initialize, right? So we already have that one, and then we take the path and the value, walk through that in case, and we take these, making the current, right? We can use that one, and if it's, then this is not a val, la la la. So type result is sema context original, and then int expressions I. return the current type. Right. Can do it like that actually. At this point, we don't seem to need context at all. So that one. Finally. And then we have, let's see here, we have the original and we have the int expression. And if not result, then we return false. Right? And let's see here, we have a few things in here. Okay, so now we want to take like the value of this one and do the rest. So we actually want to do this as well. But so now let's take the type. We take the value, which is this expression's value. So now we have, let's see, the named expression is pure. The value is pure. And let's see here, we got something. Here's our the purity of this one. So like this. Constant is also going to be like this was constant. And this one is actually going away, I think. So, because we don't need that anymore. So let's see what happens to this one. So it's going to be take the element, do stuff. When we do stuff, find element of type. If it's constant, then also afterwards we can do like expression is constant if it is constant. And the expression is pure if it is constant. Right? Because it can't change anything as long as it is constant. But now we have a problem. We have this designated initializer. Designated initializer, this one. Designated path. It is of two kinds, yeah. And I don't think our code actually did what's supposed to be, because it did just punt it here, right? So f type canonical type equals type canonical. Right. Type lowering actually. If type kind equals type array, if it's an array, we can't have a subarray here at this point. We should never have that. So if element expression kind is not a subarray, subscript, sorry. Hang on, if it's a subscript. And it's not type array here. Same error on this element. Expected an fixed size array here during initially here a fixed, sorry. So I guess this later could be expanded here, but for now it's this. And so but was instead type error this type. Okay, so this is an error, we just return, we say we did report the error. That is true. Try, okay, true, and return null. Now we know it's an array, so we are going to check that analyze schema, analyze expression value, because it has to be a value here. Sorry, it's a value, that means, yeah, so now we need the context, damn it. So context take the element, no, we want to, yeah, the element is the array type here then. Type lowered array base, and then we have the expression, which is element subscript index, because that's the only one we actually have. Right? Yeah, so that's correct. And if you fail, then we did report the error and return null. Yeah, and we don't actually, the index should be use size, right? Type use size. I think we have something here. So we have, here we have it. let's see here. So we want to cast it. Okay, we have this part. Okay, so we do that, and then we might do this and cast the end index to take that. If it fails, then we did report error. Then let's see, we also need to get the index typed. Which is assert the inner type. Actually, here we are. This doesn't make sense because we should never. We should always have the array here, right? Because we don't. I think we did. I did the wrong thing way back. Because if you have a subarray, you shouldn't be able to set elements on that. No. Is there some other case when you get this? No. Just for this. Okay. In this case, we now know what the type is. So we can actually, we have checked this. We know that the type is that. So now we can actually check that the index is in, now if we have this element subscript expression index, we can take this, we want this one here. Expression index is this. Now if this index, if we fail, ours didn't cast it. We do that. And now at this point, we might have a constant. So index, if index is constant, so if the index is constant, then this is constant. That's just the way. If index is not constant, then it is constant is false, right? If index is constant, then we can check it. So in this case, we can see big int let's see, I have the index, we have the array is already a number, so constant. Like, just pick this one, assigned, like, let's see here. So this should already be unsigned or signed here, right? So as signed, I guess. No, unsigned. If I compare this one to 0, should be const exp. If I compare that to 0 and if it's less than 0, sigma error, then we did report the error and return null. And then we can take this one as, we know it's not less than 0, then we can take this one as a value. Right? So maybe just do this. Oh. Len, right? So okay, so it's also it's okay. So size t or unsigned. Index. If index val is bigger or equal to type array length, then we get sigma error index. Index is greater than the size of the array. Greater, and then we take like the value here. What's that? I always forget the order here. This printf lu of index val. This is correct. I didn't really protest at least. So if it's and then we have an error. There's a lot of things to report in here, I guess. Don't know. So now we know it's in bounds. We know that we know everything almost. We just need the type. But this is just when, okay, this was just when it was constant anyway. Okay, and then we know like return type lowered array base, like that. We're done. So that was when it was a subscript, right? So if element only equals, I mean, can only be, like at this point, this should never be anything else. This is super important. Actually, this turns out to be super important to do these asserts, because I might change something and maybe everything just, it means that sometime what used to be true is suddenly false. So adding these asserts are like, you have to pretty much have to do it or you will get problems. That is my opinion anyway. And now we have an identifier, right? So all we need to do is like we want to assert that if type is struct-like. If it's not, if the type isn't struct-like, then sigma error index expected cannot index A does not have members. Type does not have members. So this is, maybe we just return, null here. And the reason for this is that it's probably better in this case say that, okay, we didn't actually match anything path, right? Okay, so now we know that it's a struct like, so we have we can find the our member. It's super easy to do that by iterating over it, but I don't know if there's a function for it. Maybe that's better then. So we have the type lowered struct decal, like that, and hang on, it's going to do something while we're waiting. So 1 second. Right. Okay, so we have the elements in the struct members, which is the type lowered, take the decal, and the struct, and the members, and there we have them. Members even. And now we will walk down here into this. So we go if the name of that member equals, I think we have a function for this, because there's this recursive thing here. So let's see what we have. Usage of this members. Basically, it's a super common thing, and sort of do that all of the time. So let's see here. No, it doesn't look like we're doing anything. We have the member access, and so I guess we have to have some name thing. And that's super strange, because doing this is very common. maybe I was just doing it on this in this case. Okay, so static decal schema find element of for a name, and then we have start with a set of decals, and we also have a name, and then we go through those decals and if we have the decal, if decal doesn't have a name, then we do a schema, then equals schema find element for name decal struct members such that the decal is type struct like, no, it has to be like a struct like. So if it has to be struct like, and then we go to the members, and then we can look for the name. If found, return found, continue otherwise, and if, like the first things, like if decal name equals name, return decal, right? And if it hasn't got a name, then we just return it. So return null. So this is like a primitive, just walk through everything. And I think the reason why we didn't need this before was that I did sort of push down of things. So it's let's not get into that. So in this case, we just do this find element for name of this, and we go for the name which we found in element identifier, right? So like that. If not member, then we didn't find it, so return null. Otherwise, we found it, so return the type. Right? So now we're done with that. So now the semantic analysis should be... Oh, I need context here. Ooh, it broke. Yeah, and we are down here. And we try to, basically it's trying to do the recursive set constant value, yeah. So it thinks that it has a designated expression, but it doesn't, because I just broke that, right? So so far it's going fairly well. What we need to do is, like, this has to go, right? We don't use that anymore. Let's completely obliterate that, and now we get all the failures. So why is there not one of these? It wonders. So what should I do when I expect it? La la la. And we need to remove this as well. So the designated initializer is totally gone. For some reason, I was like, okay, we don't want this. We don't want to auto hide. So here, again, we have designated something somewhere, I guess. No, I guess we have the designated up here, and we don't want that. So we don't want this. We're going to rename this named param later on, but so this is should completely go. But okay, so now this is interesting. So now we are that's the LVM thing. So let's remove this. Remove this. And we are going through the elements, and now we know we have a thing with this sort of path, right? But then we have like recursive set value, and we have the path, right? And I don't think this is correct. So yeah, we have a path, that is true. But the path is now an expression path. We take the element, which is now a named parameter, right? So it has a path. So we have the value as well. But we don't have anything funky there. We don't have a designated path. We have expressions, right? And a list of expressions. Which means that we shouldn't do the recursive concept value. We should do something like an inline, like package path, expert path element path element is path this. Okay, and if it's a if it's an path, so now we can switch over the kinds, right? And this is correct. This is actually also correct, right? But we just don't do it recursively anymore. So if we have the path element kind, and that expression kind, and that could either be an expression identifier, no, expression subscript, right? Or it could be a if it's, oh, here it is. There's a subscript. So sorry, the identifier here. So if it doesn't have a subpath, it's the. But let's just, we have the value, right? So we have the value. So you want to, if it's what are we going to do? I don't think this is a good idea, because what you want to do is you don't want to set it as a const value, right? You want to do it as a Oh, so this is this is sorry, this is where it is a const value. So in that case, you need to so the effect size, if it's the last element of the path, in that case, if it's not the if it's the last part, then we just do this. Otherwise we do this. So if it's a it's just becoming these. Alright, yeah, so if it's just something simple, we have a special case here. So let's take the size of this and do it explicitly. For unsigned I 0 less than path count I plus plus, so we get this thing again. So here we have if I equals path count minus 1. In this case, we are just going to construct a union and return. Otherwise, we're going to do this. What's the index of the path? It's going to be like alright, so we don't know what the index is at this point. We don't really care. And that is maybe a problem, I don't know. I have to think about this a bit. So let's just put a big darn to do on this one. And then we have like the we do this to memory, okay? So this is more of a normal case. And then each element now as so we have like the so this is a fairly big refactoring, as you see. So we are here, let's see here. What we're going to do is if it's a normal one, we just do that, right? And we just emit an expression. Let's see here, if we assign to a variable, right? So we have a constant, we do this la la la. We can do that. and if it's a normal, and then we have this. But we should, for each of these, we should build a gap. So this is more like what I want to do, right? This is more like it. And so why can't we do this? We are here, so we have the initialized normal. This can go away. I just brought in too much stuff. Okay, so if it's a union, we have an element, right? And if this is a union, in that case, the first element is if type equals, what was the type? So the current type is that, right? And then we have an element like that. If it is a union, then we simply take whatever we have and do a bit cast, I guess. So if it is we have the optional ref. Darn, this is getting complicated. This is getting way too complicated to do right now. Sort of at it's like already 12:30 here. So let's just skip that. Let's just see where else it will break. Oh no, it linked. Good. So we just hit the to do, right? And then we wanted to. Actually, there's a lack of optimization here, because we have this. We have a bunch of things that are putting in. I just saw some issues here, so this is okay. Const value. When we do that, we omit here. So this is too complicated. Damn it! And there are even to dos here. So let's see here. We do a like here. Let's omit this one. Look at it. It's like an adder, but nothing should be like you see here. So this doesn't look right. An expression can be an initialized list, but you should have them. You only have them once here, right? So I guess in this case, what actually happens is that this optional ref is never true. And there are a lot of improves here, and this is for creating a full literal. So I'm going to quit here because doing this is something I want to think about it a bit, because I know approximately what I did. And the one thing that is important to know is that we have this special code, which basically saying if it's sufficiently small, if you're if you have a sufficiently small struct or union, then when you do an assignment to that, you want to do a mem copy instead. So you actually create whatever you have as a constant, put that as a global constant, and then you copy from that. So you do this, and then copy maybe, you know. But the thing is, I think you need to be able to do this global thing. I think this is basically something that you want to be able to do at any time, right? So you want to be able to do create the global this evoke this one for globals, right? So it's just created in memory and stored like that. And the problem here is to do that, you do it a different way than you would with something like a huge struct. So we have we basically want to use we want to write two methods. So one is for having it as a value, which is the one that are going to be like in special cases and for the globals. And the other one is going to be for everything else. And then you do the gep, which is like indexing down into and setting the value and then going back. And those are quite different ways of thinking of things. And you can't, if I remember correctly, you can't do the it won't work on the constant. So maybe there's a constant. I'm just going to ask at the LVM group and see if there's a way to do this. But as it looks like there has to be like two ways of doing the same thing. And this will all, when I do this refactoring, it will improve things. But currently it's just adding a bit of mess. All right. Thanks you for watching, and I don't know if I'll put this on YouTube, maybe. Have a good day. Good night.